So for protection purposes, our technology has the speed and the accuracy, but now the additional range and additional number of locations that can be built in. And that's a critically important function of the system. But what we've been learning and how the technology is evolving goes into other timescales, because once you've installed a network of these sensors to pick up on faults, they're constantly out there. Even though they're passive, they're constantly streaming at incredibly high speeds, bringing back lots of information which can be interpreted and made use of. So we take the data coming from these networks for the next time scale of applications, which is what I would call real-time control. And this says we've got a sensor network out there that's constantly streaming information. Now the protection system doesn't need or use that information most of the time if there's not a problem or not a fault, but that data is inherently valuable because in real time you can visualize with some simple dashboards the status or the performance of critical pieces of HV equipment that are out there in the field, and that's incredibly useful for the people who are operating the system in the control center to be able to see an alarm and decide if it's valid or not and have an independent opinion on it, giving more information about where there's a problem, what it might be or how it's occurring. That's incredibly useful kind of real-time decision support information, and then they can make literally better informed decisions about the problem that they're seeing on their dashboards. A great example of that is overheating terminations. Very often you'll find a power cable is connected and at the connection point, which is akin to an industrial sized plug and socket, you could get overheating at that point if there's too much current flowing through. Now if that's not monitored and there's no way to send an alarm from somewhere that could be 300 miles away saying that's now becoming dangerous, it could be left and you could end up with an explosion. It's very easy for us to put a temperature sensor at that location, and because our systems are able to produce and publish alarms in an industry format, we can send a signal straight to the control center to say this looks like it's overheating and it's going from green to amber to red, if you will, so that they've got the time to react and see that there's a growing problem before it becomes catastrophic.